Hello, good morning. You're welcome to the lecture series on biological techniques. Earlier in our lectures, we had looked at the major types of microscopes, and we had said that the microscopes are distinguished into their various types based on the source of illumination, the type of imaging system that's used to produce images. Now, we had classified them into the optical microscopes, the electron microscopes, the X-ray microscopes, the scanning acoustic microscopes, the helium microscopes, the neutron microscopes, the scanning probe microscopes. The optical microscopes make use of visible light. The electron microscopes use electrons to produce images. The X-ray microscopes make use of X-rays to produce images, while the scanning acoustic microscope uses focused sound waves to create or to generate images. Neutron microscopes utilize neutron to create a nuclear fission to produce images, while the scanning probe microscopes makes use of produces image by scanning through the surfaces of the samples that have been presented or placed on the stage. We have looked at the light microscopes or the optical microscopes earlier. We had discussed the different types of optical microscopes. So today's lecture will be on electron microscopes. Electron microscopes. What are electron microscopes? An electron microscope visualizes objects with electrons as the source of illumination. The electron microscope visualizes objects with electrons as the source of illumination. Instead of using light, the electron microscopes utilize electrons to view images, to produce, to view objects, to produce images that are clearly visible. The microscopic organisms are magnified in this form. It allows much greater magnification and resolution than a compound microscope. Modern electron microscopes can magnify up to 2 million times. You can imagine, can magnify up to 2 million times, which is far more than that of the compound light microscope. Now I want to look at the types of electron microscopes and their uses. The types of electron microscopes and their uses. There are two types of electron microscopes, and these are the transmission electron microscope and the scanning electron microscope. The two types of electron microscopes are the transmission electron microscopes and the scanning electron microscopes. I want to look at the transmission electron microscopes. What are transmission electron microscopes? The transmission electron microscope uses electrons, but instead of scanning the surface as in scanning electron microscopes, electrons are passed through very thin specimens. The electrons in the transmission electron microscope are passed through very thin specimen instead of scanning through the surface. The result is a two-dimensional image. The transmission electron microscope works on the same principle as the optical microscope, but uses electrons in the place of light and electromagnets in the place of glass slides. Okay, the transmission electron microscopes use electrons instead of light and electromagnets instead of glass slides. The use of electron microscope electrons instead of light allows a much higher resolution. Use of electrons instead of light allows a much higher resolution. The transmission electron microscope is identical in concept with a modern binocular light microscope. It is composed of a source of illumination, in this case an electron source, a substage condenser to focus the electrons on the specimen, and an objective and ocular lens system. So it is actually similar in principle to the modern binocular microscope. And the electron microscope, the ocular lens is replaced with a projector lens, a projection lens. In the electron microscope, the ocular lens that's found in the light microscope is replaced with a projection lens, since it projects an image onto a fluorescent screen or a photographic plate. Since electrons do not pass through glass, they are focused by electromagnetic fields. Instead of rotating a nose piece with different fixed lenses, the electron microscope merely changes the current and voltage applied to the electromagnetic lenses. So instead of changing the objectives, the voltage, the current and voltage applied on the electromagnetic lenses is changed. Now here is a picture of the transmission electron microscope and accessory imaging systems. Similar to the compound microscopes, electron microscopes have an energy source, electrons instead of light, an objective lens, and a condenser. Images are viewed through an eyepiece or projected onto a screen or photographic plate. The electron microscope has greater magnification and resolution than the optical microscope because of the wavelength of an electron, because the wavelength of an electron is much smaller than that of a light photon. Now, having discussed about the electron microscope, we want to now discuss the scanning electron microscope, which is another type of electron microscope. We have looked at the transmission electron microscope. Now we want to look at the scanning electron microscope. The scanning electron microscope do not use light waves. They use electrons, which are negatively charged electrical particles, to magnify objects up to 2 million times. Scanning electron microscopes scan the surface of specimen with a fine electron beam. It scans the surface of specimen with a fine electron beam. Here, the electron beam is projected onto the surface of the specimen. The electron beam is projected onto the surface of the specimen. The electrons do not go through the sample, but bounce off. This way, it is possible to visualize the surface structure of the specimen. The electrons reflected back from the surface, together with other electrons that the specimen itself emits as a result of bombardment, are amplified and transmitted to the screen, where the image can be viewed and photographed. That's the mechanism of how the scanning electron microscope works. Scanning electron microscopy yields sticking three-dimensional images. It produces three-dimensional images. This technique has improved our understanding of many biological and physical phenomena that cannot be achieved with light microscope. The scanning electron microscope is becoming increasingly popular with cell biologists because of its remarkable ability to quantifiable mapping of surface detail, along with approved resolution and its ability to show 3D structures. Now here's the image of the scanning electron microscope. I want to now compare the light microscope with an electron microscope. Now with unaided eyes, one should be able to see the human height, the length of some nerve and muscle cells, the chicken egg, the frog egg. With the light microscope, it is possible to view eukaryotic cells, the nucleus of the eukaryotic cells, the bacteria, and mitochondria of the eukaryotic cells. The electron microscope allows viewing of viruses as well as some other very important cellular organelles that cannot be seen with a light microscope, such as the ribosomes, the proteins, lipids, small micromolecules, and even atoms. So the electron microscope has higher resolution and higher magnification than the light microscope. Thanks a lot for watching. We urge you to continue to watch our videos on YouTube. We appreciate it.